네, 안녕하세요. 코이 머스크의 조민호입니다. 제가 그 거의 한 40분 전에 제가 일어났거든요. 어제 발사가 거의 5시 반, 6시까지 계속 있는 바람에 제가 거의 밤을 새다시피 해가지고요. 근데 제가 저는 오늘을 아마 그, 아, 아마 오늘 일론 머스크의 스타쉽 프레젠테이션이 있을 것이다. 제가 예상은 했기 때문에 아, 제가 시간을 헷갈렸어요. 분명히 11시 한다는데 아침 한국 시간으로 밤 11시인지 아니면은 그쪽 시간으로 11시에 하는 건지 헷갈렸는데 네, 지금 스페이스X 유튜브 채널 보니까 딱 13분 남았어요. 그래서 지금 바로 저도 한 20분 전에 봐가지고 막 준비를 해가지고 좀 정신이 없습니다만은 제가 지금까지 올라온 사실을 한번 정리를 해볼게요. 지금 보자. 전체적으로 스타쉽 지금 준비하려고 지금 스페이스 X에서도 지금 굉장히 어 예고 방송을 띄워놓은 상태고요. 어차피 저도 제가 영어 약하기 때문에 제가 어차피 지금 트위터에 의지해가지고 할 수밖에 없어요. 물론 정보를 굉장히 많이 주기 때문에 그러긴 한데요. 어쨌든 지금 어, 스페이스 X 지금 분위기가 네 이제 최고조로 들어갔습니다. 한번 보시죠. 지금 수많은 트위터들이 있는데 지금 지금 현장에 지금 이렇게 랩터 엔진을 지금 깔아놓고 보시죠 지금요. 네, 랩터 2에게 해가지고 두 개 지금 랩터 엔진을 지금 깔아놓고 지금 전시를 하는 모습을 볼 수 있고요. 랩터가 지금 준비되어 있고요. 현장 분위기도 네 지금 굉장히 최고조입니다. 지금 그 옛날 그 랩터 4 아니 호퍼 3 있죠? 호퍼 3 지금 해놓고 지금 이렇게 지금 해놓고 좀 분위기가 이래요. 지금 어저께 그 슈퍼 헤비 부스터하고 지금 스타쉽 20하고 지금 결합을 해가지고 일론 머스크가 지금 하루 종일 이것만 도배를 하시거든요 트위터에다가. 그런데 거기에 지금 그 현장에서 지금 이 프레젠테이션을 좀 하겠다 지금 예상을 하고 있습니다. 이거는 여기 그 미국이 가장 그 로켓의 최전성기가 세탄보이 로켓이잖아요. 이것보다 이 슈퍼 헤비하고 이 스타쉽을 결합한 로켓이 더 큽니다. 더 커요. 이게 아마 미국 역사상 또는 세계 역사상 가장 큰 로켓이라고 이제 해도 뭐 과언이 아닙니다. 지금 뭐 중국에서 만든 로켓이 이렇게 큰 건 없기 때문에 중국에서 만든 것 또한 이번에 한 3분의 2밖에 안 됩니다. 그래서 드디어 높겠다고. 근데 이게 지금 발사가 가장 오늘 발표의 가장 하이라이트는 뭐냐? 과연 슈퍼 헤비하고 스타쉽하고 결합을 했을 때 이 결합을 해가지고 지구 궤도 발사를 언제 할 것이냐? 이것이 가장 큰 관건이라고 할 수 있어요. 그래서 이 지구 궤도 그 발사가 성공해가지고 다시 착륙이 되면은 야 드디어 화성에 이제 갈 수 있는 환경이 이제 할 수 있는 조건이 아주 가장 최적지가 아닐까 이렇게 예상을 하고 있습니다. 그래서 그 발표를 언제 하느냐? 솔직히 그게 가장 오늘 관건이라 할 수 있죠. 왜냐하면 아직 그 발사를 언제 할지 아직 결정을 못 잡았기 때문에 오늘 나오지 않을까 지금 예상을 하고 있고요. 그래서 지금 일론 머스크 뭐 트윗 보도 뭐 하루 종일 이것만 지금 나오고 있는 상황이죠. 네. 그래서 오늘 초대형 이벤트나 뭐 이것이 있지 않을까 생각이 들어요. 그래서 네 지금 뭐 이제 10분 남았다 생각이 들죠. 지금 분위기 한번 가볼까요? 어, 잠깐만요. 네. 제가 공기가 별로 안 좋아서 네, 저 1분이면 2분이기 여기서 이제 발표를 한다 얘기죠. 하고 제가 아까도 얘기했지만은 제가 영어 양이 진짜 약해요. 그래서 제가 어 그 소리를 듣고서는 제가 도저히 무슨 말인지 하나도 알 수가 없습니다. 그래서 여러분 혹시 해석이 되시면은 좀 댓글에 남겨주시면 제가 참고를 할게요. 제가 영어에 너무너무 약하기 때문에 그리고 지금 상태가 그렇게 좋지 않기 때문에 좀 내기 많이 걸릴 거예요. 예상을 해주시 어 양해를 먼저 부탁드리고요. 어쨌든 간에 이제 조금만 있으면은 스타쉽 프레젠테이션이 할 것이다. 그래서 어떤 프레젠테이션을 통해서 오늘 어떤 내용을 바뀔 것인지를 이야기 다 할 것 같습니다. 예, 많이 기대를 하고 있는 상황이죠. 그래서 일단은 아직까지 뭐 시작을 하지 않았기 때문에 아직 특별한 뭐 내용은 없습니다만은 여기도 지금 나오죠. 엄청 크네요. 그래서 가장 하이라이트는 이 스타쉽 20 발사를 언제 할 것이냐 하는 것이 될 것으로 예상이 됩니다. 그래서 어차피 여기 트위터에서도 실시간으로 계속 올려주니까요. 제가 그걸 열심히 읽어주겠습니다. 예, 10분 남았죠. 그래서 진짜 크죠. 저게 지금 몇 미터인지 제가 한 120m 정도 되는 걸로 지금 알고 있거든요. 120m. 이런 식으로 지금 야외에 지금 랩터 엔진을 지금 설치하고 있고 이렇게 지금 일론 머스크가 나와서 직접 이야기를 하겠죠. 어떻게 오늘 이 스타칩을 이제 발사하고 준비할 것이라는 것을요. 저도 갑자기 이게 준비를 해가지고 정신이 없어요. 예, 뭔가 좀 찾아보고 있어야 되는데 또 이제 스타쉽이 문제가 뭐냐면은 다른 이제 로켓 발사 같은 경우는요 우리가 일반적으로 이제 많이 보고 이제 뭐 팔컨 9 같이 왜 거의 뭐 한 달에 한 번씩 쏘는 발사체 같은 경우는 이제 정보가 굉장히 많잖아요. 아 이게 이렇게 될 것이라는 것을 예상이 되는데 스타쉽 같은 경우는 아예 다른 로켓과 전혀 다른 개념으로 만든 로켓이기 때문에 또 메탄 추진 로켓으로 지금 개발하고 있는 상황이기 때문에 어, 이게 어떻게 앞으로 될 것이다 이걸 말하기가 정말 제가 어렵습니다. 하나씩 되는 과정만 이제 조금씩 이야기를 할 수 있는 상황이라서 저도 천천히 따라가면서 이야기를 해드리도록 하겠습니다. 그래서 저도 이걸 보면서 할 거니까요. 계속적으로 이야기를 해드리도록 할게요. 그래서 뭐 다 지금 그런 분위기입니다. 지금 스타시 지금 이렇게 지금 군중들이 모여가지고 사람들 모이고 지금 여기 지금 오늘 아침에 아스트라 발사했던 스페이스 플라이트 스페이스 플라이트죠. 여기서도 지금 지금 업데이트 생중계를 지금 한 분도 3명 해가지고 같이 하고 있는데 정말 멋있네요. 그리고 분위 또 해볼까요? 이분이 어차피 뭐 이따가 계속 보겠죠. 그리고 제 노트북이 좋은 노트북이 아니에요. 지금 SSD도 불량이기 때문에 겨우겨우 지금 하고 있습니다. 그래서 천천히 보여드리도록 하겠습니다. 그래서 본 행사는 딱 정각 11시에 시작을 해요. 그래서 지금 스페이스X 지금 카운트다운에도 지금 4분 47초가 남았죠. 지금 벌써 3만 명이 지금 대기를 하고 있습니다. 스페이스 스타시에 광팬들이 꽤 많아가지고 하여튼 엄청납니다. 지금 미국 동부 시간으로 지금 거의 9시 5분 전이거든요. 예. 그럼에도 불구하고 아니 뭐 그때가 뭐 가장 핫한 시간이니까요. 예. 그래서 이제 정보가 계속 올라오면은 계속적으로 이야기를 하도록 할게요. 그래서 참 이제 저도 이 스타쉽을 처음 봤을 때도 진짜 이 저게 어떤 우주선이지? 저 그 생각이 딱 들었거든요. 그리고 저게 이제 시험 발사 한 번, 두 번 실패하고 성공 왔다 갔다 할 때 과연 저게 진짜 날 수 있어? 라고 했었는데 네 어쨌든 어쨌든 굉장히 그래도 모습을 갖췄습니다 드디어. 그리고 전번에 예전에 가장 충격적으로 충격을 줬던 거 지금 여기 지금 앞에 보이는 그 스타쉽 모습 있잖아요. 이 스타쉽하고 슈퍼헤비하고 이렇게 다 그 발사대 거치를 했어요. 그런데 이제 일론 머스크가 이 스타쉽의 젓가락으로 이 스타쉽을 나중에 스타쉽을 슈퍼헤비하고 스타쉽을 젓가락으로 잡겠다 해가지고 아주 충격과 공포로 몰아섰는데 실제적으로 아주 그 모습도 준비를 돼가고 이렇게 되고 있습니다. 그래서 진짜 그냥 겉으로 보면은 그냥 빈 깡통 같은 저 스타쉽인데 어쨌든 그 발사를 위한 모습은 갖췄다. 예, 속은 어떤지 모르지만 자, 그래서 이제 2분만 있으면 시작하니까요. 예, 뉴스가 엄청 쏟아지겠죠. 근데 제가 참 이게 어렵습니다. 이게 지금 이걸 빨겠네요. 그래서 참고하시 바라고요. 어차피 저도 공부하기 위해서 하는 거니까 다 꺼버려야겠어요. 진짜 너무너무 과부하 걸립니다 지금. 이게 걸렸구나. 제가 덱스를 세상에 걸어놨습니다. 무지하게. 네. 아, 근데 일론 머스크가 좀 저 나오는 시간이 좀 걸린다고 뭐 하기도 해요. 이게 이게 지금 트위터에서도 뭐라냐? 원래 지금 9시 다시 시작해야 돼. 근데 일론이 실제로 그 EST가 원래는 미국 동부 시간이잖아요. EST 이스턴 타임. 근데 이 또 비꼬는 말로 일론 스탠드 타임을 해가지고 일론이 실제로 나오는 시간하고 다를 수 있다. 이렇게 지금 아주 재밌게 아주 이야기를 하고 있어요. 저 이거 좀 처음 만드네요. 어쨌든 간에 공식적으로는 이제 1분을 남겨놓고 있습니다. 음, 자, 다시 한번 미리 말씀드리면은 내기 많이 걸려요. 그래서 양해를 부탁드리고요. 더 내기 더 걸리는 것 같아요, 이게. 또 걸렸네, 이게. 지금 상태가 안 좋아서 겨우겨우 버티고 있는 상황인데요. 짚고 가겠습니다. 너무 많이 걸립니다. 네, 지금 시작하죠. 네, 지금 시작하겠습니다. 그래서 딴 데 안 가고 그냥 그 트위터를 중심으로 해가지고 이야기하는 것을만 충실하겠습니다. 제가 어쩔 수가 없어요. 로켓 발사도 아니고 참, 오랜만에 드디어 일론 머스크의 스타쉽 프리젠테이션을 시작합니다. 아마 사실 팬들한테는 아마 올해 최고의 1년 중 최고의 행사가 아닐까 생각이 듭니다. 네, 지금 시작이 됐죠. 지금 다른 트위터에서 뭐라냐, 지금 일론 머스크는 스페이스X의 우주선 개발 프로그램인 궤도 발사에 대한 업데이트를 지금 제공한다 이렇게 되어 있습니다. 거의 스타쉽 위주로 이야기할 것이다 예상하고 있어요. 음악 빵빵히 틀면서 순간성을 만들어가지고 죄송하다고 그런 트위터를 하고 그러네요. 네, 시작했죠. 힘드네요. 와, 무려 지금 4만 9천 명이 진행은 되고 있습니다. 원래 밥 먹으러 가야 되는데 이걸 할 줄 상상을 못했네요. 야, 슈퍼에이브가 저는 쇼스리바에서 슈퍼에이브 더 멋있어요. 저렇게 큰 부스터가 준비를 주는 상상을 못했거든요. 야, 저렇게 해가지고 드디어 완전히 스트레 아주 풀 배치가 이제 다 됐어요. 야, 시작합니다. 일론 머스크 바로 등장했네요.
Hey. All right, welcome. Welcome. Welcome to
네,
Starbase.
스타베이스.
So it's been almost 2 years since
2년
our last
만에.
update, and a lot has happened since then. By the way, I'm getting like a strange audio feedback. I don't know.
영상 한번
Do I sound okay to
켜놓겠습니다.
you guys? Okay, great. So it's been 2 years. since we had our first Mark I rocket, and a lot has happened since then. We're going to go through the progress, but I'm just incredibly proud of the SpaceX team and all the support that we received from Cameron County, from Brownsville, from South Padre. I know some of you in the audience, so thank you very much for your support.
다 감사한다고.
So,
마지막 업데이트가 2년 전에 이루어졌다는 얘기죠.
So before we jump into the details of what's happened over the past 2 years, I think it's worth just talking a bit about this, like why are we doing this? You know, this, I mean, pretty epic, but what's the sort of deep meaning behind this? Like, why build a giant reusable rocket? Why make life multiplanetary? And I think this is just an incredibly important thing for the future of life itself. So, and there's both I call it the sort of the defensive reason or the life insurance reason. That's one part of it, which is that there's always some chance that something could go wrong on Earth. The dinosaurs are not around anymore. So, you know, we could, there could be some calamity that where we do ourselves in, or there's a natural disaster. Now, I'm naturally an optimist, so I think the probability of that is low, but it is not zero. And eventually, the sun will expand. It might take a few 100 million years, so don't hold your breath. But eventually, the sun will expand and destroy all life. So for those who really care about not just the humans, but all the life on Earth, it is very important, essential, that over the long term, that we become a multi-planet species, ultimately even go beyond the solar system and bring life with us. And you know, we are life's stewards, life's guardians. You know, the creatures that we love they can't build spaceships, but we can, and we can bring them with us. And I think that's pretty important, you know, for those that care about the environment and care about all the creatures on Earth. So that's like I would say like the defensive or the life insurance reason for life collectively. But there's also an inspiring reason, which is that life can't just be about solving problems. There have to be things that inspire you, that move your heart, that make you glad to be, when you wake up in the morning, you're excited about the future. And going out there and being a multi-planet species and being a spacefaring civilization and making science fiction, not fiction forever, I think that's one of those things. You know, I think that's what fires me up the most, is like, let's go out there and find out what this universe is all about. You know, are there other species out there? Maybe. You know, hopefully it's. I mean, we want to go find out what the heck's going on. What is going on? I mean, how do we get here? What's the meaning of life? 42. But what's the question? And you know, if we go out there and we explore the galaxy, ultimately, we can find out some of those questions. And it would just be very exciting to do that, and something we can all look forward to.
아마 창을 올리는 게 더 나을 것 같아요. 제가 말하는
And even,
것보다는요.
you know, whether somebody chooses to go or not, I think, you know, vicariously we can all go there. Just like with Apollo, where, you know, only a handful of people went to the moon, but in a sense, we all went there. Humanity went there, and so even if somebody doesn't choose to go themselves, I think vicariously through others, they will go, they will understand, they will experience the universe. And I think that's incredibly fundamental to an exciting future. And that's why we're doing this. So. And Yeah. Now, one of the rebuttals we'll sometimes hear is like, sure, but what about all the problems on Earth? And I completely agree that the vast majority of resources should be dedicated to solving problems on Earth. Absolutely. I'd say like more than 99% of our resources should be oriented towards solving problems on Earth. So it's important to note that like NASA's annual budget is
그
only
미국 그 예산 중에서 그 차지하는 나사 비율이 너무너무 적다. 나사,
And in fact, of the national GDP, it's less than a tenth of a percentage point. So it's like we're only spending 0.1% of our resources on space. I think that's okay. You know, like we'll be fine. You know, so just just make sure people don't think like, well, is he suggesting that we just spend everything on space? No, I'm suggesting like maybe 0.5% or something like that. We'll probably be okay. And I think given this establishing security for life itself and having an exciting future and inspiring kids about the future, I think it's worth it, basically. Yeah. So, well, how do we do this? How do we make life
나사의
what's the
그
first
예산은
step?
적고 하지만 그
And,
국방부에서 이제
The
스페이스
essential
우주의 진출에는 많이
technology, the
있다.
holy grail
스페이스에서
breakthrough that's
비로소
needed
많은 그
is
많은
a
혜택을 받는다.
rapid
이렇게
and
나올
completely
거예요.
reusable rocket system. So this has never been accomplished before. And a lot of people for the longest time thought this was not possible. Now with Falcon 9, we've been able to show that you can have reuse of a boost stage and reuse of the fairing. So with Falcon 9, we've demonstrated a lot of reuse of the boost stage and of the fairing. We've have over 100 reflights of the fairing over of the booster, and I'm not sure of the fairing number, but it's a lot. And that's a big step in the right direction. With Starship, we're aiming for full and rapid reusability. So, we obviously need to accomplish that. That's not done yet. But the success is one of the possible outcomes, which I always think is when embarking on an endeavor, success should be at least one of the possible outcomes. And for this design, that is the case. And we're aiming for rapid reusability, which is why the booster is going to take off and then fly back to the launch tower and aspirationally land on the arms, which does sound insane, or as Bill Riley would say, audacious. But if it does come in too fast and shear off the arms, then I guess it will be a farewell to arms. Sorry. There's the dad jokes, I have to warn you, they're only going to get worse. Here I'd really just like to congratulate the SpaceX team.
펠컨 9이 발사됐다.
And also
그래서 140번
thank NASA, the
발사했고,
FAA, the Space Force,
106번 그
and
재청을
everyone, and all our
성공했고,
customers
엄청난 기록을
that
세웠죠.
have helped us get to this point. It's insanely hard to get a rocket to orbit. Insanely difficult. I have huge respect for anyone who's gotten a rocket to orbit. It's so hard. And we've had 144 successful launches, 106 landings. Actually, these days I have to look on the internet, say, how many landings have we had? I'll have to ask the internet. 83 flight-proven launches. Although I have to say, I still have like launch PTSD every time the rocket takes off. I'm like, I just see all the ways that it could fail. Like, but you know, and then this year we're actually aiming to have around 50 launches, so it's about a launch per week on average, and yeah, so it's a hell of a year we got ahead of us, and in terms of mass to orbit, if you look at like tonnage to orbit, this bar chart that we'll show here really illustrates how profound a rapidly reusable rocket, especially a big one, is, what effect that has on total tonnage to orbit. So the total mass to orbit to date of Earth is around 15,000 tons, maybe 16,000 tons. And
저 그래프는 세계적으로 전체
the mass
발사
per
총,
Starship
총
after
질량하고
a year,
스타쉽의
just 1 year
질량하고
of
이제 비교를
launching,
하는
as
것
if it
같아요.
launches 3 times a day, would be equal to all the mass to orbit of Earth to date. That's just one Starship launching 3 times a day for a year. Now, if you have, you know, 10 Starships-ish,
세 번의 발사를 통해서
then, and we'll have more than that. Our goal is to be making at least a one stack per month.
앞으로 이제 발사를 많이
and then
하기로 저렇게
ultimately,
우리가 더 많은 것을
potentially a
발사할 수
ship
있을
every
것이다.
3 days.
그런 것 보여준 것 같습니다.
There'll be more ships than there are boosters because the booster actually, even though it's gigantic, will come back in about 6 minutes.
엄청나게 쌌을 것 같아요.
Excitement guaranteed. So it only takes about 2 minutes on ascent and then about 4 minutes to return. So you'll know soon. The ship has to complete at least 1 orbit around Earth, and sometimes maybe 3 orbits or more, and each orbit is 90 minutes. So the ship is probably, you know, reusable about every 6 to 8 hours. That's why we say sort of 3 times a day for the ship. But in theory, the booster is capable of being reused every hour. So the propellant pumps are designed to fill the rocket in
주당
about
거의
half an
3회
hour.
발사하겠다 지금 이야기를 하고 있는
So
거죠.
this really is designed for rapid reusability. So if you can do roughly a million tons to Earth orbit, that's comfortably over 100,000 tons to the surface of Mars, maybe 150,000 tons, depending on how good the landing system is. So now you can only go to Mars every 2 years. And I think maybe roughly you need about 1 million tons on Mars to have a self-sustaining city. But the critical threshold, I think, for Mars is to have a city that is self-sustaining. It's going to be incredibly difficult to make a self-sustaining city because if it's missing any ingredient at all, however minor that ingredient is, then if the ships from Earth stop coming for any reason, the city will die out. So the critical threshold to pass
3일마다 한 번씩 우주선을 진수한다.
one of the most
그리고
important great
우주선은
filters
6시간에서
for any
8시간마다 재사용 가능한
species
세계를 완료해야
is to
되고
have
부선은 몇 시간 사용할 수
have
있다.
the
와,
other planet
합니다.
no longer
예,
dependent on the original planet. So
진짜
I don't know exactly what
엄청나게
that
발사할
tonnage
것
is, but I suspect it is at least
예상이
if
됐죠.
one
또
tries to get the
스타쉽
right
발사
order
때도
of
엄청나게 많이
about 1
세운돼
million
있으니까요.
hopefully it's not more than that. Starship is capable of doing that. It's capable of getting 1 million tons to the surface of Mars and creating a self-sustaining
그리고
city.
거의 화성 표면에 100만
we should try to do
톤
that as soon as we
정도의 화물을 사람과 화물을 보낼 것이다. 이렇게
The
나오고
window of
있습니다.
opportunity may be open for a long time, and I hope it is, but it may also be open for a short time. And this is the first point in the 4.5 billion year history of Earth that it has been possible. I mean, let that sink in. Or if there's a sink, let it in. still knocking at the door. I mean, it's a sentient thing. Let's face it. Let it. I mean, come in. So 4.5 billion years. It's been a while. This is the first time it's been possible. We need to seize the opportunity and do it as quickly as possible. I mean, to be frank, civilization is feeling a little fragile these days. And like I said, I'm an optimist, but I think we got to protect the downside here and try to build that city on Mars as soon
자급도
as
아주 그
possible.
화성에 자급적 도시 만들기 위해서는 화성에 약 100만 톤
And it's going to
필요하다.
be an incredibly exciting adventure. Now, the sales pitch for going to Mars is that it's going to be cramped, dangerous, difficult, very hard work. You might die, and that's the sales pitch. I hope you like it. So far from being some sort of escape hatch, it will be extremely
화성에 가는
difficult
것은 위험하고
and
어려울 것이기
dangerous
때문에
and
지구상의
tough.
생명체로부터의 탈출구가 아니다. 그 자체도 위험성이 엄청 크다는 얘기죠.
Mars is a fixer-upper of a planet, and so it's going to take some work to make it easy to live there. But one day we could make Mars a planet like Earth, and I think we should. So just some facts about Starship, and these numbers will evolve over time. So the height of the ship is about 50 meters, 164 feet. The 9-meter or 30-foot diameter. Well, you can just see it basically. It's got about 1,200 tons of propellant on the ship, and thrust is about 1,500 tons. Now these numbers will we'll probably add more propellant over time, increase thrust.
견적 다
Diameter
들었습니다.
will stay the same.
높이가 50m,
Huge
길이가
change
9m,
diameter.
직경이
So
9m.
that'll tend to stay the same, but it'll probably get a little bit longer. And we're expecting payload capacity of 100 to 150 tons, depending on which orbit. So to a Starlink orbit, roughly 100 tons.
와, 진짜.
Over time, I think we can probably get the orbit for orbital refilling, the payload to an orbit for orbital refilling to about 200 tons, which is going to be very important for getting to Mars. So for getting to Mars, you also need the orbital refilling. Just like you have aerial refueling, the rockets will need orbital refilling. It's actually mostly oxygen. There's 3.5 tons of oxygen for every 1 ton of fuel. So that's why it's refilling, not refueling. So heat shield. So this is the world's largest heat shield. And this is we actually make this at
저게 이제
at a little
방열판이에요. 아주
factory
열심히
in
촘촘히 잘
Florida near
박았죠.
Cape Canaveral. We call it the bakery, and we're actually using a lot of techniques that are used for roofing tiles. So we need to have a heat shield that is capable of resisting extreme heat, but also is not crazy expensive. And our heat shield team has done amazing work in creating the world's largest heat shield, and one that is reusable, but also robust and low cost. So it's not a crazy money heat shield, and yeah, need good heat shield technology for entering from orbit. Orbital refilling. We were going to do an animation of this, but it looked a bit wrong.
저러신가요?
It is a fluid
쌍으로.
transfer. So, yeah, play a little Barry White, you know. Okay. So that's one of the technologies that is necessary for getting to Mars. So the ship would get to orbit with its payload, and then in orbit we'd refill the tanks, so it would have enough propellant to get to Mars. Mars is far. So now this is essentially docking in orbit, and with Dragon docking with the space station, this is a technology that that SpaceX has become quite good at. We've done, I think at this point, a couple dozen dockings with the space station, and it's actually way harder to dock with the space station than to dock with yourself. So this is, it is a thing we need to solve for Starship, but I'm confident that we can do this because we've done a lot of orbital docking already with Dragon. But this is going to be an important thing to demonstrate. Won't be necessary in the near term for Starlink launches, but it will be necessary for Mars and the Moon. So let's see, the Super Heavy booster. So it was 70 meters, but then there was an extra half barrel section that the team deleted, and totally accidentally it's 69 meters. It's also booster 4 and ship 20. I mean, this is a pure coincidence. Those numbers won't leave me alone. It's just, I hope it's good luck. So propellant capacity is like around 3,400 tons. I think like I said, it'll probably it will increase over time. Probably get to 36, maybe 3,800 tons. Thrust is around 7,600 tons. That'll probably increase too over time. Just to put this into perspective, though, the Saturn V was 7.5 million pounds of thrust, and
아까 그
Starship
쌍으로
is
있는 게
17.
슈퍼헤비 지금 얘기하고 있고요.
So it's more than twice the thrust
푸사시 궤도
of the Saturn
재충전
V.
위치가 궤도에서 재충전을 한다는
That's the largest
얘기네요.
rocket ever to get to orbit. It's worth noting Super Heavy is the largest flying object of any kind, or will be. It's yeah, very big. You can see it right there. That booster has 29 engines. The next booster, we actually increased the engine count to 33. We've kind of bounced around on engine count, but because I think at one point we had like 37 engines, and then we went to 29. We finally settled on 33 engines, which is about actually the most number of engines you can actually fit under that booster without like expanding the diameter. Yeah, and then this tower, this tower from design to construction was 13 months, so it's quite an epic structure. It's really worth emphasizing that the whole launch system, which is basically stage 0, is I'd say as complex and difficult as either the booster or the ship. So I really want to emphasize that this is and it's a very difficult thing that requires a lot of hardcore engineering.
엔진 수가 33개네요.
And it's really, like I said, the tower and the launch system, which I call stage 0, is just as important as stage 1 and stage 2. I mean, this is really some wild stuff here. In fact, I mean, hard to believe it's real, except, you know, it's right there. So, yeah. Then after development, Raptor 1 was 185 tons of thrust. Raptor 2 is 230 tons of thrust.
슈퍼헤비가 33개인데 지금 부스터 4인데 그것보다 4개 더 많다.
Probably 250 tons. So that's and it's also significantly simplified.
저게 몇
You can see the
엔진이죠?
difference between V1 and V2. The V2 is V1 looks like kind of like a Christmas tree spaghetti pile. A lot of fiddly bits. And V2 is greatly simplified while also increasing thrust at the same time. So it actually Raptor 2 costs about half as much as Raptor 1, despite having much more thrust, and I think just generally being a much easier engine to build and a more robust engine. So very excited about Raptor version 2, and it's only going to get better from here.
연소 실험 한 걸 보이고 있고요.
Yeah. So so Raptor 2 is pretty sick.
또 걸렸네.
And
네,
we've
걸렸어요.
actually the peak thrust that we've
죄송합니다.
operated Raptor 2 at this point is 247 tons.
죄송합니다, 여러분. 다시 보여드리겠습니다.
One of the essential keys to, I mean, it is essential, obviously, to making Starship work. It'll be the first full flow stage combustion engine to get to orbit. Yeah, kind of need that ISP and thrust to weight. So why Starbase? A lot of people like say like why Starbase? Why here? And we kind of needed a confluence of factors. The getting to orbit, you want to launch eastward so that you have help from Earth's rotation. So the closer you are to the equator, the more of a sort of a boost from Earth rotation that you get. So you want to be as south as possible and launch eastward. And then, it's always possible that something goes wrong. And so you want to have a good clear area. You want several miles around the launch site to be unpopulated or at least clearable. And that doesn't actually leave a lot of options. It's basically here and Cape Canaveral or Cape Kennedy is where are the other two possibilities. And then because we have had a lot of launches going out of the Cape, we didn't want to disrupt the Cape activity, the operational launches, with sort of the advanced R&D of Starship. So it was important to decouple the operational launches from the R&D launches, and that's why we're at this location. And once again, I'd just like to thank Cameron County and the Brownsville South Padre and the remaining residents of Boca Chica Village. Where I live, by the way, it's my primary residence is that little village over there. So, and it's been great. It's been great being here, and super appreciate the support of the community. Anyway, thank you. So I think we've got a video to show what we hope will happen with launch. We'll play it now.
뭐 나와야 되는데. 나온다. 지금 궤도 발사 언제든지
sorry.
어커밍 스타쉽 미션에 나오죠
We
지금요.
have some upcoming
이게 지금
Starship
가장
missions.
중요한 거는 이제
Orbital flight is really just the beginning.
지구 궤도 발사가 언제 할
So
것인가.
we're going to have a number of Starlink missions that will launch Starlink satellite version 2. But even more exciting than that is the NASA human spaceflight mission. We're incredibly honored that NASA has selected Starship to take astronauts back to the moon for the first time in half a century, which is kind of mind-blowing. So,
달로 가는 스타쉽 만들어낸다 그런 거죠 나사를 위해서.
I'd just like to say, like, we're SpaceX is just deeply honored and appreciative that NASA would choose us for this incredibly important mission, and we'll get it done. And then there's also the Dear Moon mission, which is going to take artists around the moon, and that's Isaku Miyazawa, and he's going to select I think a dozen artists and do a loop around the moon, which will be very exciting. And there's going to be some future announcements that I think people will be pretty fired up about. So. anyway, super exciting future ahead with this. There'll probably be a few bumps in the road, you know, but we want to iron those out with satellite missions and test missions and get to a high flight rate and then have something that's extremely reliable for human spaceflight. So, yeah.
영상 보여주셨죠? 스타쉽 그 상상도를 좀 보여주고 있네요. 와, 멋있다. 일단 보도록 하겠습니다. 이게 이제 새로운 개념인 그 지구 궤도에서의 재충전 작업이라고 얘기를 했습니다. 두 개가 붙어가지고. 화성 도시를 보이고 있네요. 스타쉽 발사장이 지금 굉장히 많습니다.
All right.
네.
Let's make this real. Any questions?
질문이 없냐고 물어봐요.
Let's make this real.
뭐 말이 필요 있습니까? 아 웃겨.
Fire away. Anyone? I can't see you, so you probably just have to yell it out or something.
아 너무 웃기다 진짜.
Yes, there's 6 Raptors on Starship. Currently 3 with the vacuum nozzle, 3 sea level. Sorry?
Check.
And I think if I would say like we'll probably end up adding another 3 vacuum engines. They kind of, fill in the gaps and stretch the ship. I think is going to make a lot of sense.
아 너무 웃기네 진짜.
You'll have to yell, unfortunately. We are building
멋있습니다 아주.
a launch site, a Starship launch tower.
네, 지금 벌써 지금 유튜브에 올라왔습니다.
At Cape Kennedy, and we are also building a Starship production facility at the Cape. So we'll have production facility and launch site here, and a production facility and launch site at the Cape as well. It's important to have redundancy.
Hi, Yvonne. It's Irene Klotz with Aviation Week
네,
over here.
질문을 받네 이제.
I've got lights in my eyes, so unfortunately I can't see.
Okay, well-
I'm blinded. So I can hear where
We're
the
all
speaker is
here.
coming from.
Okay.
But,
You should. I believe you're expecting to hear in a couple weeks about the possible finding of no significant impact from the FAA. Have you gotten any indications if that's going to come through, and what is your time frame for the orbital flight test? Thanks.
well, we don't have a ton of insight into where things stand with the FAA.
있습니다.
We have gotten sort of a
모르겠어요.
rough indication that there may be an approval in March, but that's all we know.
So, hi, Elon. Marcus Hervey. Can you talk about the point-to-point capability? Is there a possibility between here and Cape Canaveral?
Oh, well, yeah, I guess technically yes. So, I mean, depending on how good things get with Starship, there are some scenarios where it might actually be the lowest cost means of transporting cargo long distances.
제가 링크 올려드렸습니다. 링크로 다시 보시기
So the
바랍니다.
interesting thing is that
다시
the
발사
capital
이니셜.
efficiency of a rocket is much better than the capital efficiency of a plane for long distance flights. So now this would really be more for if you're going like, I don't know, a quarter or a third or halfway around the world, where if you went from, I don't know, say here to Singapore or something, like that's a long flight. So I mean, I don't know how long that is. I'm not sure you can even go there nonstop, but it's probably like 20
연방
hours
항공청하고
plus.
계속 지금
And
많이 많잖아요. 그래서
but
3월 내에 아마
in
승인이
a
날
rocket, it
거다
would be less than
이야기를
an
하고
hour.
있는 상황이죠.
So like 45 minutes or thereabouts. So that means you'd be able to use the rocket 20 times more often than an aircraft. So it's 20 times the capital efficiency. So provided the propellant cost is competitive with aircraft, and bear in mind, like I was saying, there's 3.5 tons of liquid oxygen for every 1 ton of fuel. And liquid oxygen is basically just the cost of electricity, because it's in the air basically. There is a scenario where it's economically compelling to do long distance cargo and people transport with Starship. That'd be very cool, and I think that'd be great for getting a high flight rate and a business case for supporting a lot of Starships operating. And basically, nothing's faster than a nice EVM.
We got a question right here, Elon, right in the middle, right here, right, hands up in the middle.
I mean, I literally have lights in my eyes, and it's pitch dark in front of me.
It's fine. Hi, Elon. Michael Sheets with CNBC. You opened this presentation by addressing a little bit of the criticism that's been aimed at space travel being seen as maybe a pet project or not really valuable to folks who have problems here on Earth. I was wondering if you could get a little more into the specifics on comparing not just the U.S. government spending that's happening on space travel versus other things, but maybe in terms of SpaceX itself, how you and private investment on a dollar value compares to the taxpayer-funded projects or contracts that SpaceX has won over the years.
Well, I think objectively, the cost efficiency of SpaceX is the best in history, I think, for any rocket development, and we are talking about a rocket that's more than twice the mass and thrust of a Saturn V, and also designed to be fully reusable, which is obviously also much better from an environmental standpoint to have a fully reusable rocket, for a development cost that is, I don't know, between 5 and 10% of Saturn V. So that's pretty good. Because we need to make it work, so it's not worked yet, but it will work. Might be a few bumps along the road, but it'll work. I feel at this point, highly confident that we'll get to orbit this year. That's we're making a lot of rockets, making a lot of engines. We're close to achieving a Raptor 2 every day production rate, so 7 a week, which is tough for a complex engine. And I think by the end of this year, we'll be able to produce a ship and a booster per month. So this is I don't know, at least an order of magnitude, maybe 2 orders of magnitude more efficient than anything in the past. Yeah. So.
Hey Elon, this is Joey Roulette for Supercluster. Just wondering, what does SpaceX's plan and timeline look like if the FAA ultimately decides to do a deeper environmental review of Starbase? And then one other thing,
네,
you might be able
진더머스크가
to give us an
스타쉽이
updated figure
올해 안에 궤도에
what it
지구 궤도에
costs
들어갈
to,
것이라고 확신한다.
Starship and what it would
맞습니다.
cost a customer to buy a flight on one. Thanks.
Yeah, I mean, I am optimistic that we will get approval. I think objectively, I think this is not something that will be harmful to the environment. We've obviously flown the ship several times and done multiple landings and taken landings. We fired the engines.
스타쉽은 아마 세턴 V의 한 5에서 10%, 20%밖에 안 된다. 그래서 올해 궤도에 오를 것이고 하루에 1랩터, 4터 이제 하나씩 만들 것이다. 이렇게 하고 있습니다.
Things don't get delayed from a regulatory standpoint. And we are in a litigious society, and so there's always sort of lawsuits from someone, lawsuit city. Now we do have the alternative of the Cape, and we actually applied for environmental approval for launch from the Cape a few years ago and received it. So we actually are approved from an environmental standpoint to launch from 39A. So I guess our worst case scenario is that we would, I don't know, be delayed for 6 to 8 months to build up the Cape launch tower and launch from there. From a cost standpoint, the costs will improve significantly over time. So because it'll take us a moment to achieve full reusability and full and rapid reusability, we'll probably lose a few vehicles along the way. With Falcon 9, I think it took us 14 or
승인
15
여부를 물어보고
attempts
있어요. 지금
to
영국항공체 승인
successfully
여부.
land the first booster. I don't think it'll take us that many with Starship because we have that experience.
환경 영향 평가를
but
해가지고
it's,
지금 버가 취재에 대한 지금
certainly not a sure
발사 승인이
thing
안
that
나고
will work the
있거든요.
first time.
그것 때문에 지금 그 얘기를 하고 있습니다.
I mean, from a cost standpoint, I mean, it's a 100-ton capability to orbit. On a marginal cost to launch basis, that doesn't count fixed costs, which obviously have to be covered. It may be as little as a few $1,000,000 per flight, maybe even as low as $1 million per flight. So this is crazy. These are crazy low numbers by space standards.
예, 지금
Very
만일에
crazy low.
승인이 아예 안 나가지고 그 케이프
Now,
캐나버럴로 가게
we do
되면은
have to cover fixed costs.
6달에서
So,
8달 더 연기가 될 것이다
depending on what
이렇게
our
이야기를
launch
하고
rate is, we
있고요.
have to
이제 좀
divide the fixed cost by the number of launches. So
최악의
the more launches
경우에는
that happen,
될 것이다 이야기를
the lower
하고
the
있는
total
거죠.
cost, fully considered cost per flight would be. But I'm highly confident it would be less than $10 million all in over, if you say like fast forward like 2 or 3 years from now. I think it's highly likely to be everything included less than $10 million a flight for 100-ton to orbit capability. And 100 tons to a useful orbit, not to a low orbit. To a low orbit, it would be 150 tons. So this is ridiculously good compared to everything else. And it should be because, if you think of like, if this was if aircraft were not reusable, how much would an air ticket cost? I mean, it's like, for, I don't know what, a 787 or 777 goes for these days. I don't know, a few $100 million. If you had to spend, $200 million every flight, it would be very expensive to fly somewhere, and you'd need 2 of them for, another one for the return trip. So, it would obviously be absurd. So if you can imagine if we were in a world where
사실은 저기도에
aircraft
지구
were expendable,
저기도에 약 150톤을
and
보낼 수 있을 것이다 지금
someone came
예상하고
along with
있네요.
a reusable aircraft, it would be an absolutely profound game changer. That's what needs to happen for life to become multiplanetary, and that's what this design, I'm confident, is capable of that. It's just a question of how long it will take to refine that and have it really dialed.
Hi.
Hi.
Hi. Sorry, this is Andrea Leinfelder of the Houston Chronicle. I wanted to know, when and how do you plan to test Starship refueling in space? And also, aside from NASA, Dear Moon, and Starlink, can you elaborate on the potential customer base for Starship? Thank you.
I apologize. I zoned out for a second. I was just thinking about something. Could you say that question again?
Sorry. When and
We have some mic issues.
okay, when and how do you plan to test Starship refueling in
Oh,
space? And aside from NASA, Dear Moon, and Starlink, can you elaborate on potential customers for Starship? Thank you.
I think orbital refilling, and I want to emphasize it is refilling, not refueling, because it's 3.5 times as much oxygen than fuel. So we mostly are carrying oxygen up there. I optimistically, towards the end of next year, I think I'd be surprised if it's longer than 2 years for doing the refilling. And there are a lot of additional customers that will want to use Starship. I don't want to steal their thunder. They're going to make their announcements, and but I think this will get a lot of use, a lot of attention. It's like I said, once we make this work, it's an utterly profound breakthrough in access to orbit. And when you have an utterly profound breakthrough, the use cases will be hard to imagine. I mean, when aircraft first came along, they were aircraft were viewed as toys, like they were like a novelty, not a means of transport. They were like, oh look, we can fly like a bird briefly and dangerously for a few minutes. Nobody at the time, or at least I think very few people at the time, thought that there would be a global aircraft industry with airports throughout the world carrying people to every part of Earth in ridiculously short periods of time. When the Wright brothers first took off, I mean, most people were just riding horses. So you're like, oh, like riding a horse, see this crazy device, looks like witchcraft. And they would not have imagined that there would be aircraft flying, tens of thousands of aircraft flying to every corner of the world. So I think we made this really could be an extremely profound situation, and we really can't even imagine all the use cases at this point. So.
Hi, Elon. This is Steve Clark with the Brownsville Herald. Thank you for the presentation.
You're welcome.
So if the FAA does come back and say we need an EIS, does Starbase bounce back from that at some point?
Yeah, I mean, it would obviously set us back for quite some time because an EIS takes a lot longer than an EA. So we would have to shift our priorities to Cape Kennedy.
Okay, and long term, what do you envision for Starbase? Like a spaceport with flights coming and going and Starship manufacturing, or what is the future role of Starbase?
The future role of Starbase, I think, it's well suited to be kind of like our advanced R&D location. So it's like where we would try out new designs and new versions of the rocket, and then I think probably Cape Kennedy would be our sort of main operational launch site, and then. I don't know, over time, I think we'll have floating spaceports, like ocean spaceports. We got these 2 converted oil rigs that are going to be turned into orbital launch sites. And they can be moved around the world. So, I think there could be quite a few of those.
지금 일론 머스크 같은 경우도 지금
I think about like
보카체차치의 지금 환경 영향 평가가 이제 걸려 있어가지고 3월까지 아무것도 할 수 없어요 지금. 그냥 그 연방항공청의 그 결정을 기다려야 되고, 만약에 연경항공청이 이거 환경이 좀 문제가 된다 그러면은 이제 케이프 캐나베라로 이제 옮겨가야 되는데 그것도 대략 6개월에서 8개월 걸린다. 예, 그 얘기를 계속 지금 하고 있습니다. 지금 환경 영향 평가 이제 발목이 잡혀가지고 굉장히 좀 어려운 상태다라고 이야기를 하는 거죠.
Probably most of the launch sites long term will be kind of ocean or sea spaceports. So like maybe located like 20 miles, 30 miles offshore, and this would allow Starship to connect
석유
any
굴착
cities
장치
that are on the ocean or on the sea.
결국은 해양 발사대도 이제 만들 것이다 이렇게 이야기를 하고 있는 거죠.
Disturbing people too much. I think people are willing to have something that's loud occasionally, but if you want to have it frequently, then it probably needs to be offshore.
Hello, Elon. I'm Cam Gerlach with the SpaceX Reddit community. So you've talked a lot about how Raptor 2 is crucially important for Starship development and for the future of Starship. So I'm curious, what general improvements have you made with Raptor 2 to ensure it's not only more efficient and more powerful, but also much easier to produce and less expensive as well and faster? And how do you plan to continue to iterate further on the design in the future?
So, Raptor 2 is an almost complete redesign relative to Raptor 1. So basically, everything from the turbomachinery to the chamber nozzle, the electronics, basically everything's been redesigned. You can see the difference over there, the Raptor 1 versus Raptor 2. A lot of the changes were deleting things. We deleted a lot, consolidated a lot. The rotating machinery, especially the inducers of the turbo pumps, are a lot more robust. We converted a bunch of flanges to welds, and we're actually over time will convert even more flanges to welds. I hate flanges, especially if you've got high pressure and a cryogenic fluid or super hot gas. Flanges and seals are a nightmare, and so we've got parts of that engine that are sort of 700-800 bar, sort of 11,000-12,000 psi, which is nutty, and so just going to welded joints instead of flanges was pretty helpful. The pre-burner controllers have been consolidated into a sort of a unified box as opposed to being kind of like all over the engine. And we're getting close to the point where I think Raptor will not need shrouds. So shrouds are a huge pain in the ass, like basically putting a whole shield around the engine, especially for the gimbaling engines, where it's got to kind of have like a sort of eyeball seal, like it's like rotating in a circle with a hot gas seal. With a bit more deletion and integration, I think the engine will be sort of flame proof, more or less, and then we can get rid of the shrouds, which would be a big mass savings. Yeah. So a lot more could go on. We're also operating at a higher chamber pressure. I think we can probably operate. I think over time we can operate it at 330 bar sustained in the main chamber, and without having the pre-burner pressures be too high, by essentially not by losing less pressure. There's like a whole pressure ladder going from the turbo pumps and pre-burners to the main chamber, and by getting rid of a bunch of the choke points, we can have less pressure loss, and so the pumps can effectively produce more pressure in the main chamber due to less loss in the secondary systems. Do you have any? Have specific questions or?
Sorry, Chris Gephardt with NASA Spaceflight. Can you talk a little bit about the abort modes that are available for ship if there were ever to be a problem during the climb to orbit? What would be available to the crew in that regard? And also on that same level, the life support systems for ship. Where do those stand, and what are the challenges that you're finding with just the sheer volume in Starship for that? Thank you.
So Starship will not have an independent abort system, but I think something that would make sense is to have the thruster weight of the ship be enough that it could do it could take off from the booster, even if the booster has a failure at the pad level. So if you can get the thruster weight of the ship at sea level above 1, then even if there is something goes wrong with the booster, the ship can essentially fly away from the booster. And so that's something that I think would be important for carrying people, and also for high-value cargo, to have the ship have a thruster weight greater than 1 even at sea level. And then there's like I said, that would be like the 9-engine version. And then even if you lost one engine, I think you should still be able to do an abort. So I think for crewed missions, we would essentially maybe detank the ship to some degree so that you'd have kind of a launch abort capability with the ship, even if you lost an engine. That'd be my recommendation. From a life support standpoint, we would have a sort of sort of a renewable, like for long, we could scale up the life support system in Dragon. That would certainly be an option, and that would work for missions that are, say, a week or 2 weeks. That would be fine. For missions to Mars, you'd want a life support system that is renewable. So it's essentially recycling everything in a closed loop system with close to zero loss to mass. So that would be a more advanced system, because you'd have to convert the CO2 back into O2 and kind of recycle, poop and urine and stuff. So that's a harder problem, but it's not an immediate problem. We can certainly scale up Dragon for any kind of missions that are, a few weeks long.
Hi, Elon. Eric Berger with Ars Technica. Thanks for taking some questions. I'm wondering if you do get that approval from the FAA in March. I know that there's really no way of knowing, but could you talk a little bit about the hardware readiness, sort of where you are technically? The launch tower is pretty incredible, but sort of the rocket, the ground systems, software. Like if you were to get some kind of approval from the FAA in March, would you be looking at, how quickly could the hardware be ready to go?
Yeah, I mean, I think we're close to having the hardware ready to go. So right now, I think we're tracking to have the regulatory approval and hardware readiness around the same time. So around the same. Hopefully, basically a couple months for both.
Hi, Seth Krakowski with SpaceExport.com. You mentioned launching from the sea. Could you give us an update on the current status of using Phobos and Deimos for Starship operations?
Yeah, so Phobos and Deimos thus far have been a relatively low priority. We needed to make the launch site here work. This has been quite a difficult endeavor. So we deprioritized the Phobos and Deimos. And just last month, we started to. We're going to take one of them and build at least a catch tower on it. So, and ultimately we will. Ultimately meaning, like, I don't know, later this year, build a full launch capability on one of the platforms. So I think hopefully by the end of this year we will have a launch capability at Cape Kennedy at 39A and on one of the ocean platforms as well.
Hi, Ellen. This is Adam Cardona with CBS 4 and NBC 23 here in the Rio Grande Valley. This is more of a community-based question. This past week, several BISD students, community leaders, and community members got together to ask you a question and to show their gratitude. Not sure if you got that message yet, but they were saying thank you, Elon, and they wanted to know if you would be able to attend their Charles Days festivities here in Brownsville. So on behalf of them, will you be attending Charles Days?
It sounds like fun. So, like, when is it?
I believe it starts on the 19th through the 25th. So you have several days to attend Sombrero Festival, Charter Days parades, enjoy some great food. Will we see you there?
I will be there.
All right.
That's going to be hard to follow up. Hey, Elon. Tim Dodd, the Everyday Astronaut here. Okay, so a little bit more Raptor 2 talk again. Where are you at as far as production? How many do you have? How are they handling, testing? Are they more cantankerous, less cantankerous? Just give us a little more rundown, like on where you're actually at. Is that a bottleneck for the next booster as well? We assume the next booster is going to require, Raptor 2. So, kind of where are you at with the production and the testing so far?
아니고요.
Well, right now, of any technical problem, I'm spending the most time personally on Raptor 2. Like really, they're like the two things that occupy the most number of mental cycles are Raptor 2 and Tesla Full Self-Driving. The only remaining issue that we're aware of is melting the chamber. So that thing really wants to melt, you know. It's got like on the order of a gigawatt of heat, so it's pretty hot. Like a gigawatt's like what a nuclear power plant produces, so it really is desperately trying to melt at any point in time. We've got, we're flowing an immense amount of cryogenic fuel to cool the chamber in the channels. We have head-end film cooling. We've got throat film cooling, and we're just trying to get the exact sort of balance between head-end film cooling and throat film cooling to not melt the chamber. I think we're pretty close. Like we have a couple engines in the stand that have I think 700 or 800 seconds of operation and several start cycles. So it's looking positive, but that's the remaining issue is melting the chamber. But in the meantime, we're scaling up old production to get to 1 a day or better. So apart from melted chambers, we're doing well. We've got a lot of pumps, a lot of electronics, a lot of pre-burner controllers. Just not melting the chamber, which is very difficult, is the kind of the last remaining challenge. But I think we're very close to solving that. And then the production system has a lot of momentum. Like I said, we're really, like next week we'll probably make at least 5 or 6 Raptor 2s, for example. Yeah. And I think we'll be at a 7 a week or better by next month. But those are crazy. These are crazy numbers for rocket engines, by the way. Yeah.
Hi, Elon. Robert Perlman with Space.com and Collect Space. You mentioned the NASA contract for the human landing system. At one point, do you envision splintering off development of Starship for HLS, or how are you going to balance the timelines of rapid reusability versus NASA's own schedule of when they're ready to go to the moon?
I don't think there's really a conflict there. We're going to be making a lot of ships, a lot of boosters, obviously a lot of engines. Yeah, it's kind of interesting. Like with the booster with 33 engines and the ship with 9 engines is 42. There we go again. And that also total coincidence. Adding legs to land on the moon, we do not think is like that can be done pretty quickly. I don't really see any conflict between achieving rapid reusability and getting to the moon. A high production rate solves many ills. So we're aiming for a high production rate.
Hi, Lauren Grush with The Verge. I'm wondering if you can clarify the number of launches that you plan to conduct in order to do these refillings. I know a lot of numbers have been thrown around, so I'm wondering if you have landed on a final number, and how quickly do you plan to launch those missions back-to-back to refuel the vehicle to get to the moon? Thanks.
Yeah, so the missions would happen pretty fast for refilling the vehicles to minimize boil-off of the cryogenic propellants. Now for the vehicle going to the moon, we have some installation to minimize boil-off. But we'd probably be launching, I don't know, probably every few hours, aspirationally. So, yeah.
Hi, Elon. Kevin Haymeyer from Space Eccentric on YouTube and Rumble. Thank you. My viewers are really hungry to know anything about the interior design for crewed Starship. You have HLS, you have Deer Moon, and last we heard, maybe a year or two ago, you were looking to hire Tesla employees to design the interior for Starship. How's that going?
Well, we aren't focusing a lot on the interior quite yet. I mean, that will be important down the road, but our focus right now is just getting to orbit and proving out return of the booster and return of the ship. Yeah, it's fundamentally very difficult to build a fully reusable rocket given the strength of Earth's gravity and the density of our atmosphere. Like there's no, you can't have a lot of mass margin. So our focus is solving that rapid reusability. Like I said, we'll have a high production rate, so we're not dependent on full reusability, but really that's the breakthrough that's fundamentally important to change the course of human civilization to become a multi-planet species.
Elon, this will be the last question for you.
Evening, Elon. Bob Duncan. I'm a local resident.
We're cutting out the mic.
Are we cutting out? Is that better? Hi, evening. My name is Bob Duncan. I'm a local resident here in the area. And first off, thank you for a very cool evening. So this has been a lot of fun for us. As a local resident, it's been exciting to watch the amazing progress that SpaceX has made here in Boca Chica. And I was just curious, we're standing on the southern tip of the state of Texas. We're a few hundred yards from your residence. Could you just speak to what, if anything, has been appealing or advantageous about operating in the state of Texas versus other parts of the country? Thank you.
Well, I think we've, well, I mean, we've had a lot of support from the community, and something that just happens over time with societies is that kind of rules and regulations build up, and they build up, more in some places than others, and they didn't, I think Texas has the right amount of rules and regulations. Yeah. So, thank you all for coming. I hope you've enjoyed the evening, and I think we might be able to get you closer to the rocket if you'd like. So we'll get you as close as possible while still being safe. Yeah, feel free to take pictures, have a good time, and let's go like hell to have an exciting future. Thank you.
끝났습니다. 자, 여기까지 봐주신 모든 감사하고요. 저 욕심없네요. 새로운 모르는 데도 많아가지고. 네, 지금까지 봐주신 거 감사드리고요. 저도 방송가 끝난과 동시에 끝내도록 하겠습니다. 지금까지 봐주시면 감사하고 나중에 또 정리해가지고 이게 아마 기사로 나올 거예요. 근데 특별히 많은 내용은 없고 올해 안에 발사할 거죠. 네, 다음에 또 뵙도록 하겠습니다. 지금까지 부족한 방송을 봐주신 거 감사드립니다.